It's James McIntyre again, Training Manager at Nortec. Check out the other videos in the Mini VRF installation video series for more information. So we're going to get into more of the nitty-gritty of installing a VRF system. The beauty of this being in video format is that if you miss anything, you can always rewind and watch it again. With a system that can use up to 984 feet of liquid line, you can imagine that piping is very important. With communicating equipment like this, it is also imperative that the system is wired correctly. In my opinion, none of this is hard. There are rules, and if you follow those rules, then it is simple. It is simple. I didn't say it was easy. If it was easy, then you and I would be out of a job. At its most basic, a mini VRF piping system has a lot of similarities with a traditional split heat pump system. You have one liquid pipe and one gas pipe, or colloquially known as suction pipe, in a 1-to-1 combination, or where you have one outdoor unit and one indoor unit. It is exactly the same as a regular heat pump. In the example, we have 3 indoor units. Notice how each main pipe Ys to every indoor unit. We're able to do this Y with what are called Y branches. These are designed specifically for an even distribution of refrigerant to either side. Do not attempt to make your own, please. T's will not work. Like I said, there are rules. The first rule is how these Y branches can be installed. They can be horizontal or vertical in either direction, but they need to be level or plumb. They cannot be sideways as indicated by those X's that mean no. They can have a pitch of 15 degrees in either direction and can rotate by 7.5 in either direction. You may not have a protractor or another instrument that shows you degrees, but you do own a level. If it is level, then there is no question. The next rule is the minimum distance between Y branches, elbows and Y branches. Let's call this the 20-inch rule. As long as you have 20 inches between each, you'll maintain proper flow and it won't be noisy. Would you say piping is important? I say it, so you should too. The quickest way for a beautiful system to become scrap is poor piping. So let's talk about our piping rules. All of the measurements we will use henceforth are in one direction. In other words, if you were to just measure the liquid line length, that's the length we are using. Our first entry is our maximum length from our outdoor unit to our farthest indoor unit. This is up to 393 feet actual and 492 feet equivalent. That is a very long line length, wouldn't you agree? Most of you will never see a site like this, particularly if you concentrate in residential. If you do end up being close to this limit, give me a call because I'd like to visit Michael Jordan's house too. So if we were to follow the piping from the outdoor unit, we'll eventually reach a Y branch. This is known as the first branch. There is only one first branch no matter how you try to pipe the system. So the distance from the first branch to the farthest indoor unit must be less than 131 feet. This is important. If you are more than 131 feet, you need to move your first branch or last indoor unit. Although we've seen this beast push refrigerant 393 feet and back, pumping up and down is significantly more difficult. So the max height difference between indoor units is 49 feet, or like only 3 or 4 stories. If you were to install this outdoor unit above the indoor units, like on a roof, the outdoor unit can pump all the way down to 164 feet to the lowest indoor unit. In the opposite configuration, like where the outdoor unit is pumping up, your highest indoor unit must be 131 feet or less from your outdoor unit. If you add all the piping up in one direction, right, that total length cannot exceed 984 feet. That is a lot of piping, wouldn't you agree? For those equivalent length limitations, you have to factor in that Y branches are considered to be 19 5/8 inches long. As you can imagine, 99.99% of the time, potential VRF sites are well within these limits. In the 0.01% left over, you can probably move some equipment around or reroute the piping. If not, I honestly have no idea what magical piece of equipment you'd use. Although those rules might sound complicated, the easiest way to skirt all of that adding up is to use our VRF selection software. All of the piping rules are pre-programmed in to ensure you won't make a mistake. Do we have other rules? Of course. Avoid traps in piping at all costs. For those that you can avoid altogether, mitigate the trap by lengthening the bottom of the trap or use 45s rather than 90s. If you question an installation, feel free to send us a picture and we'll help you out. As far as mitigating the effects of the trap, also remember that you must have at least 20 inches between elbows. We are all brazing experts, right? That's a fact, obviously. But even brazing experts like us need to brush up a bit. First off, do not install sight glasses. They'll show you absolutely nothing useful. Take your youngest tech, right? Send him out on a unit with a sight glass. If he sees bubbles in the sight glass, what will he do? That's right, he'll add refrigerant. Don't add one, and he won't just automatically add refrigerant. Next is filter dryers. Unless you were told to install a filter dryer, by me, do not install a filter dryer. With the compressor protections built in and the fact that a broken winding or short will stop the compressor immediately, you are not going to have compressor burnouts. If there are contaminants in the system, they come from installation. We do have a process for adding them if needed, but again, contact Mr. McIntyre at Nortec before adding one. Next, we have dyes and leak stop. Do not put these in a system, period. There's always that one thing you wish you knew before showing up on the date of installation. Well, one is that you'll need adapters for your refrigerant hoses. Our and nearly every other VRF and mini split manufacturer's connections are 5/16 inches instead of quarter. All of these products are available through Partner's Choice or through your Nortec brand distributor. As a matter of fact, check out Managing Mini Split Connections for more info. See that black tank in the middle? That's the thing everyone says they use all the time. If you use it, please continue to do so. If you don't use it, well, I don't really have anything nice to say. It's nitrogen. Anytime you're brazing, use nitrogen. For your pressure tests, use nitrogen. You know, dry nitrogen. You need a regulator that can handle a pressure test of 550 psi, so it'll probably say about 700 psi on the gauge. On the left is how the inside of my piping looks after brazing. On the right is my sales manager's piping after brazing. I'm kidding, of course. The black substance is carbon, right? PVE oil, or the type of oil we use in all of our VRF and mini split products, is a pretty decent copper cleaner. It'll take all of that black stuff in your piping and take it back to your compressor. Over time, this can cause excessive wear and tear on the internal components, contribute to oil breakdown, and spray black oil all over your brand new Nortec shirt when you disconnect your hoses. Sometimes you may find that your piping is smaller than your Y branches or brazed connections. First, please check that you have the right size. Second, use a reducer if it is the right size. We have all of these piping rules to ensure proper refrigerant flow and oil return. Don't force all of that effort to go to waste with 5 minutes of laziness. Use a reducer. You may or may not know this, but most of our units have flared connections, just like mini splits. Often, flare connections aren't done right, so they'll leak. Then they'll be tightened some more, then they might break. People will use leak lock, they'll cuss, and they'll get mad. All of this can be prevented by flaring correctly in the first place. This has been a complaint since flares were invented. To see how to properly flare and what tools ensure 100% success, watch Proper Flaring Technique and Verifying a Proper Flare under HVAC Tips at edgetechhvac.com. To start, you'll want a good flaring tool with a sharp cutting wheel. The one pictured is from CPS and has a setting for hard or soft copper, and it automatically tightens as it is turned. Don't over-tighten while cutting your copper. A deburring tool is important so we have a nice surface on which to flare. The only foolproof method to determine if your flare is the right size is by using a flare sizing gauge. If it is too small or too large, you'll cut it and try again. You must use a 45-degree flaring tool. I like using a flaring tool with a built-in clutch. It helps to prevent over-tightening. Now that we can make a proper flare, we need to tighten it correctly. The only way to know how tight it is to use torque wrenches. This also prevents over-tightening and the thinning of a flare. Every installation manual has a chart showing you the amount of pounds-feet or Newton meters for tightening. Select a value within these ranges for the corresponding size and set your torque wrench accordingly. Always use a backup wrench like an adjustable wrench. Never use slip joint pliers as it will strip the brass fitting. I had to change these a little to stay out of trouble, but everyone knows what they are. Do not use any type of joint compound or sealing tape on our flares. If it is leaking, cut it off and try again. I have found small blue balls inside of returned units in the past. Don't let that be you. Let's talk about the easy stuff now. Piping insulation. We do have guidelines for thickness and thermal conductivity, but the important thing is to check with the insulation manufacturer to determine the proper thickness for your environment. Chances are the type you have been using will suffice. However, all piping must be insulated. That's liquid and gas, all of it. Got it? Good. Y branches have insulating pieces included. Leave those off and leave your flares and other joints exposed until a pressure test has been completed successfully. Any leaks are much easier to find that way. When finishing the insulation, leave no gaps. You do not want condensation ruining drywall or ceiling tiles. With every indoor unit, we have peel and stick insulation wraps large enough to go around your insulation and flare nuts. So let's discuss some hints we've gotten from folks in the field. First, locate exactly where you're going to install your units or go ahead and install them, like hang them or mount them. Now, estimate where your Y branches will go. Then measure your proposed or estimated length. Now you can enter this data into our VRF selection software just to make sure our piping sizes haven't increased from our original estimate at the piping design stage. Now that we've talked about physical installation and piping, let's talk about wiring. Always, always, always follow national, state, and local codes. All of our VRF indoor units are 208-230 single phase. Although you may not all be certified electricians, I have to point out that all of the indoor units have a very low current rating, as little as 0.3 amps and as high as 1.3 amps. What this can mean is that they could be wired to the same breaker with their own disconnect. They could be if your codes allow it. Another example is providing a single breaker in the panel for each indoor unit while providing another current protection device within the disconnect serving that unit. You must have a way to safely de-energize your equipment. One way is to use a properly rated 2-pole switch. I invite you to read aloud with me. Your wire size must match the rating of the breaker and equipment in accordance with the national, state, and local electrical codes. For a great connection for your electrical wiring, I suggest using fork-type connectors. Now let's talk about wiring in the outdoor units. Our mini VRF outdoor units are also all 208-230 volt single phase. You'll need a properly rated disconnect for each outdoor unit. I again suggest using an appropriate electrical connector at your terminal block for a solid connection. You can route your wiring out of the front or side via standard knockouts. There is no safe area to mount your disconnect on the equipment. Please don't try it. Mount on an adjacent wall in accordance with local codes. We'll cover this a little more later, but let's go ahead and talk about it in case you're watching this on the job. Your outdoor unit has to have power for 8 solid hours prior to commissioning. This means our crankcase heaters are bowling any liquid refrigerant out of the compressor, ensuring a safe startup. So a quick guideline to using your time wisely is to install your piping, pressure test, pull a vacuum, weigh in any needed additional refrigerant, and open your service valves, the liquid line being first. Have your outdoor unit wired in and apply power for 8 hours. During that 8 hours, finish insulating your piping, complete any ducting, wire up power and communication for your indoor units, watch more of our amazing videos, etc. If you follow it in that order, there shouldn't be too much wasted time. To round out our installation videos, we have to talk about communication wiring. Our communication is set up using a 2-wire CAN bus, with its main advantage being that it constantly checks for communication errors. In other words, you can lose one indoor unit and the system will continue to operate, unlike pretty much every one of our competitors. Using 18-gauge wire, you can run up to 3,280 feet of wire. Should be enough. You'll be using 18-gauge stranded 2-conductor wiring. Shielding is not required. If you use 16-gauge, you can run up to 4,920 feet, which should be more than enough. Please do not use solid wire like regular thermostat wire. Now, the question I would ask, will using a solid wire guarantee a communication error? No. Will we tell you to replace it if you do get communication errors? Absolutely. To wire the units up, you'll be wiring in a daisy chain starting with the outdoor unit terminals D1 and D2. From there, we go to our first indoor unit, then to all of our other indoor units, and then to our last indoor unit, in a chain. There, we will be installing a resistor across D1 and D2 at the last unit's terminal block. This is included with each outdoor unit. Remember, I said that the communication line is in a daisy chain. Well, I was right. You cannot wire it into a star pattern or a T pattern as indicated by the subtle incorrect and no in the diagram. Our wired controller, or thermostat as everyone calls it, is the WRC1, or Wired Remote Controller 1. It has a sleek look and a backlit display with touch-sensitive buttons. It features many capabilities like mode adjustments, an auto changeover with adjustable dual set points, an on and off timer, child lock, and built-in infrared sensor for using a wireless controller if you want. These are included free of charge with every ducted unit, while ductless units have wireless handheld remotes. This controller can be used with all of our VRF indoor units. These controllers wire into the H1 and H2 terminals on the indoor units. You're using the same 18-gauge stranded, non-shielded 2-conductor wiring you used for the main comm line. You can install these controllers in one of 4 different ways. The most common option is to wire one controller for one indoor unit. Not as common, you can wire 2 controllers for one indoor unit, like in a large room where 2 controllers might be more convenient. In even bigger spaces, and the second most common configuration, we can control up to 16 units with one controller. You're more likely to see around 4, however. The temperature sensor used in that case is configurable. Please note that the daisy chain rule still applies. Now, I have only ever seen this set up once, and it was under very special circumstances that I won't explain in this video, but it's better to have an option than to not have it. You can control 16 units with 2 controllers. They don't have to be wired in any particular order, but you must maintain a daisy chain. Thanks for watching this mini VRF piping and wiring video. I hope you have been well informed, if not also highly entertained. The next video in the series discusses the commissioning of mini VRF units titled Mini VRF Commissioning. See it on edgetechhvac.com.